Hi everyone, this is Miss Sarika, and in this video we are working on comparing functions. This is a 8th grade Common Core standard, so let's get started. I'm going to read each situation and then I'm going to answer the questions by analyzing and comparing the different linear situations. Okay, so question 1. The Metropolis Zoo recently celebrated the birth of 2 new baby pandas. Ooh, how exciting. Mochi, the panda cub, has been measured and weighed each week since she was born. So as I can look down in my table, I know that at 0 weeks, she weighed 1 pound. So when she was born, she weighed 1 pound. She is 0 weeks old. At 1 week, she weighed 5 pounds. At 2 weeks, she weighed 9 pounds. And at 3 weeks, she weighed 13 pounds. I actually annotated the first problem to help you guys. The y-intercept is always when x is 0. So when x is 0, y is 1. That is the y-intercept. Okay, and then we need to find our slope. So I want to find my slope before I even look at these questions because I know it's going to be important in the questions. So to find our slope, we use that equation we've been working on for so many weeks. y2 minus y1 over x2 minus x1. So here are my y values, here are my x values. 9 minus 5 over 2 minus 1. 9 minus 5 is 4. 2 minus 1 is 1. And I get my slope to be 4 pounds per week. What a strong little panda bear, growing so very strong. So I have my slope for Mochi and I have my y-intercept. And remember, the y-intercept is when the weeks, when the x value is 0. So now let's look at Mochi's brother Kappa. Mochi's brother Kappa, we can find out how much he weighed when he was born because that's going to be the y-intercept as well. Because when he's 0 weeks old, he is born. But this time we're not given a table, we're given a graph. And let's remember the definition of the y-intercept. It's when the line crosses the y-axis. Well, the y-axis is the vertical axis. And look, this is where it crosses. And you know what's really kind of annoying about this graph, I'm going to be honest, is it doesn't tell you this exact point. We can just tell that it's between 0 and 4. And it's about halfway between 0 and 4, which is about 2 pounds, give or take. But automatically, I know that Kappa weighs more than Mochi because Mochi weighed 1 pound at 0 weeks, and Kappa weighs, it definitely looks like he weighs more than 1 pound at 0 weeks. So let's say Kappa weighs more. And remember, I used the y-intercept to find this. And I was given the y-intercept in 2 forms, one in a table and one in a graph. I already found the slope for Mochi, how much she's growing per week. Let's see if we can find Kappa's. Well, I'm going to use the exact same equation, y2 minus y1 over x2 minus x1. You guys are probably saying that as you were watching the video, so good for you. So let's use this point. I'm going to use this point and the y-intercept. That's easy. So this point is 2, 8. And this point, what did we say? We said about 0, 2. Perfect. So it's y2 minus y1, 8 minus 2, over 2 minus 0. 8 minus 2 is 6. 2 minus 0 is 2. And I get my slope to be 3 pounds per week. And I know that you might get a little bit of a different slope depending on what you said this value was, but I guesstimated, I think it's a pretty good guesstimate that this point is 0, 2. And so I get my slope to be 3 pounds per week. And it looks like Mochi is growing faster than Kappa. Again, your values might be a little bit different depending on what you said the points were on Mochi's graph. I'm definitely going to write a strongly worded letter to the person who created comparing functions. They should have told us what those points were. So for me, Mochi grows faster because her slope was 4 pounds per week. and Kappa was only 3 pounds per week. And last but not least, which panda will weigh more at 5 weeks? Well, we have to set up some equations. So let's remember y equals mx plus b. I already know the values. How lucky is that? My slope, and so this is Mochi's y equals mx plus b equation. We know that Mochi, the slope for Mochi we said was 4, so it's 4x, and what is my y-intercept? Plus 1. And then Kappa, Mr. Kappa, we said his slope was 3. So I'm going to plug that in for m, 3x. And then I said his y-intercept was 2. Again, if you don't think that that y-intercept is 0, 2, you might have said 0 and 2.5, 3, up to you. So we might get a little bit different, but that's okay. So here's Mochi's equation, and here is Kappa's equation. So to find out who will weigh more at 5 weeks, all I need to do is plug in 5 for x. Because remember, x stands for number of weeks. So I'm going to do that work a little bit so you guys can see. Let's do it right down here. Y, again, pulled out a marker that did not have ink. Woohoo. So I'm going to plug in 5 for x. Y equals 4 times 5 plus 1. So y equals, well, 4 times 5 is 20, plus 1 is 21. So our little Mochi is going to weigh 21 pounds at 5 weeks. And Kappa, we're going to plug in 5. So it's 3 times 5. So y equals 3 times 5, which is 15, plus 2. Our little Kappa is going to weigh 17 pounds. Small little guy. And so that is how you do number 1. I think number 1 is a fabulous problem, and I hope you guys thought so too. Feel free to comment on any of the issues you might have had with this video, or if you did something different, I'd love to hear about it. Again, I don't want you to stress too much if you got a different y-intercept for Mochi's brother Kappa, and if your slope was a little bit different, because again, the graph did not do a great job of specifically telling us what the points were at, so we kind of had to guesstimate. Again, I will write a strongly worded letter to them. Okay, see you later. Bye-bye.